Cleaning up SFM dictionary files is a tricky business because interpreting SFM files is often a tricky business. SFM is an aging file format that is compact but ambiguous. An SFM file is basically just a long flat list of fields, but groups of them must be interpreted as separate records, and then each record must be interpreted as being structured hierarchically. This interpretation is not supplied by the file itself, as you can see here, but rather by convention. Software for editing SFM data ought to be able to validate the data as it is typed in or pasted or imported. Standards ought to be defined and followed so that humans and computers will have a decent chance at interpreting the data correctly. This becomes especially crucial when the original people who gathered the data become unavailable. Paratext is a good example of an SFM-based editor that checks structure and promotes following a standard, the USFM standard. If I type or paste data in, it flags errors using red text. As I fix them, the red text should disappear. Structural markers, such as C, are not considered omittable just because the marker could be inferred based on the child markers or the context. Instead, it is a required field. Also, to work around some of the inherent ambiguity of SFM, closing tags for footnotes and figures have been added. By the way, closing tags are one of the advantages of XML. The situation with dictionaries stored as SFM is not so happy. In fact, it is dire. Here, the three LX markers represent 3 records, and within them there are senses, some of which are begun by an SN field, some by a PS. A dictionary record is structured as a tree, in which a given word, an LX or an SE subentry, can have multiple senses. The word has a set of fields, and each sense has its own set of sense-level fields, each under an SN or whatever begins the sense. Likewise, a given sense can have multiple examples, each one under an RF. Additionally, the MDF standard allows important structural markers to be omitted because they can often be inferred, but inferring these automatically can actually be quite difficult or even impossible. In this example, it was easy. A typical problem is that the part of speech for a given sense can't be assigned, or is assigned from the wrong neighboring sense or subentry. Here on the left we can see there are 2 nouns and 1 transitive verb. But on the right, it's unclear whether there's 3 nouns. Initially there seemed to be, because the PS is inherited downward. But then we encounter a PS under the SN. The inconsistent ordering of PS and SN makes it difficult for the computer to interpret this correctly. Existing SFM-based editors for dictionaries can sometimes check the contents of individual fields, but they do not check the structure. Unfortunately, people often don't become aware how serious these issues are until a computer tries to interpret their data for them. The moment of truth often comes when trying to publish the data or migrate it to a newer tool such as Flex. The Flex import wizard for SFM is designed to do a lot of guessing. It does well at a quick and dirty import, but for most fields, if you want a clean and accurate import result, you'll want to first clean the data up into extra tight MDF, and then work around several problems with the Flex importer as well. So rather than trying to interpret and migrate the SFM all in one step using the wizard, it's safest to clean up the SFM file itself first, ideally with the original linguist's help. Solid is a tool specifically designed to check and clean up SFM dictionaries. Once it's set up, running Solid periodically just for checking is quite safe. But for now, the uninitiated user should never edit and save there. The first time you open an SFM dictionary file in Solid, you need to specify a template. This template will be copied into the same location as your dictionary file and given the same name, .solid. The settings shown in the top left pane will be stored in that .solid file. Modify those settings to get fewer errors or more errors showing up in the bottom left pane. These represent all the errors found in the file based on whether or not each field marker occurs under a valid parent field. For example, SN can only occur under PS, and that's shown in this column under Structure. The PS marker can only be found under SE or LX. There are also settings for controlling how often a field can occur per parent, and you should almost always choose one of the first 2 options. The marker settings can be sorted by name or by count. Sorting by count is often helpful in finding very rarely used fields or typos. The very rarely used fields may best be turned into note fields so that there's less to manage, and typos, for example this d_id field and d_ind field, should be modified so that they're correctly dn fields instead. We can ignore the writing system and lift columns unless we plan to be exporting directly to lift XML from solid. To browse all records in the lexicon on the right side, click the LX field in the top left. You may need to click away on a different field first and then click on the field that you want. This will show all matching records on the right side, so you can get to the first record and then browse one by one. You can also use the search button to find specific entries. Errors are indicated by turning the field markers red. In this case, the first SN and second SN fields are both marked as errors. This is a mostly good record with only a few errors. In this case, the SN field is marked, but the actual problem is the VA field. If we very carefully highlight and cut and paste this up, and then use the small refresh, we can see that the problem goes away. The other refresh button is for rechecking the entire file, and that's what you need to click when you have changed a setting in the top left. Alternatively, we could have solved this by leaving the VA field where it was, but changing the setting to allow VA to also be a child of PS. Unfortunately, there are a lot of bugs in the editing pane of Solid that make it unsafe to do editing there for most users. This web page explains how to work around and safely edit despite those bugs. After the cleanup, it's best to migrate to a safer file format, one that's XML based rather than SFM based, and a safer editing environment like Flex or Wesay. And when archiving, to archive XML files, be sure to include a lift file. If necessary, another option is to keep editing as SFM, but to periodically check the structure using Solid. The .solid file should then be included when archiving, since you've used it to indicate the file's structure.